I want to talk to you about what's been going on in the news. It's the lead story right now coming from Japan. We want to talk about the situation with the nuclear reactors over there. We're going to give you some of the science behind this story. How does a nuclear reactor work? Where is all this energy coming from? And then what does this term meltdown mean? And what exactly happens in a nuclear meltdown? So we're going to try and sort out what's going on behind the scenes here.
Now, when the earthquake hit Japan, the nuclear reactors went into safe mode. The control rods were fully deployed, and this effectively shuts down the nuclear reactor. Now, the only problem is that while those control rods can stop neutrons from one fuel rod from traveling over and causing atoms in another fuel rod to split, it can't prevent the splitting of atoms or the nuclear fission within the fuel rods themselves. Now, you still have heat being generated because of those processes. There's only about 6% of the total amount of output heat, but that's still enough to increase temperatures in the core. Now, normally in a nuclear reactor, you have water flowing over those fuel rods. It's carrying away that heat. It's converting it into steam, which is turning a turbine to make electricity. So in Fukushima, when they lost power and those pumps were shut down, that water wasn't flowing over the rods and carrying away that heat. Temperature started to rise, pressure from steam started to build up inside of the reactor, and all of a sudden, you've got a very dangerous situation.
If it keeps getting hotter and hotter and hotter, once you hit 2,200 degrees or 2,200 degrees Celsius, the uranium inside of these fuel rods actually starts to melt. It turns into a viscous fluid. And when that happens, it flows out of the rods and it flows down into the bottom of the nuclear reactor here. But if that were to occur, there are still a few safety measures in place. For example, in this nuclear reactor in particular, the whole nuclear core is cased within stainless steel. And at the bottom here, you have 6 inches, a 6-inch thick layer of stainless steel. Now, steel is a very good conductor of heat, so it's going to remove a lot of heat from that molten radioactive material. So it will hopefully cool it down. If it doesn't cool it down enough, and eventually that material melts through that bottom layer, it'll eventually hit another layer. It's got a layer of concrete down here. And so that should hopefully slow it down as well. Worst case scenario, and we're in no way here yet, but worst case scenario, it then melts through the concrete and it seeps into the ground, and then over time, that radioactive material would eventually decay and over a very long time lose all of its radioactive potential.